Now this is the time to discuss about aim 15. In this aim 15, we are going to learn about some axioms and which are related to the congruent figures. Congruent? Okay. Let us discuss about the meaning of the congruent. Before going to the congruent, let me explain about some similar figures. And here we have two types of figures. Some are similar figures and some are congruent figures. Let me discuss about these two topics. First of all, similarity. First of all, similarity. What is meant by similarity? Simple. The figures which have same shape is called similar figures. The symbolic form of the similar figures are this one. This is the symbol for similarity. The figures which have the same shape. So generally we can say all squares are similar, all circles also similar. Why? Because they are always in the same shape. Let me draw similar figures. All circles and squares. See, these are similar figures, and squares also. If you observe, these two figures are in same shape, and these two figures also are in the same shape. And moreover, we can say all line segments also similar figures only. In this way, we can say what is meant by similar figures. The figures which have the same shape are called similar figures, and the symbolic form of the similar figures are this one. And we can say similar examples of similar figures are all circles, squares, and line segments also. And what is the property of similar figures? If any two figures are similar to each other and their corresponding sides are in the same ratio. And here the important thing you have to note that is corresponding sides of the two similar figures are in same ratio. Now let me discuss about congruent. What type of figures are said to be congruent? Here the difference is that from similar figures, the figures are in the same shape, we can call them as similar figures. Whereas in congruent figures, the figures which have same shape and same size. And similarity means the figures which have same shape only. Same shape. It is enough for the similarity. Coming to the congruent. What is meant by congruent? The figures which have same shape and same size also. Then we can call those figures are congruent figures. The symbolic form of the congruency is this one. We can indicate the congruent figures with this symbol. Let us draw some congruent figure shapes. Examples. The circles with the same radii are called as congruent figures. Those circles should be with the same radii. Means if this is 2 centimeters radius and this also be 2 centimeters only, the line segments with same measurements. Suppose it is 4 centimeters and the next one is also must be 4 centimeters only. Then only we can say those figures are congruent figures. And what is the property of the congruent figures? Means the measurement of the figure should be same. Not only shape, measurement, size also be equal. The difference of the similar figures and congruent figures are similar figures can have only same shape, whereas congruent figures have same shape and same size also. The property of the similar figures are in this, the corresponding sides are in same ratio, whereas in congruent figures measurements of the side should be same and their areas also should be same. The symbolic form of the similar figures is this one, whereas congruent figure symbol is this one. And here we can say all congruent figures are similar. All congruent figures are similar, whereas all similar figures are need not be congruent. And let me explain some congruency rules of the triangle. And here we have some axioms. Before going to that, let me show you some figures which are congruent to each other and which are similar to each other. See, are these similar figures or congruent figures? Yes, this is the circle and this one also circle. These two have same shape. So we can say these two are similar to each other. Are we called these are congruent figures? No. Why? Because these two circles are not equal to each other. Why? Because this radius is different to this radius. These two circles have different radius. So we cannot say these two are congruent. These two are similar figures only. Let me show you two more circles. See here. Are these similar figures or not? Yes. Why? Because this is the circle shape and this shape also circle. And these two figures are similar. Can we say these two figures are congruent? Yes. Why? Because the radii of these two circles is same. They are coincide with each other. They are coincide with each other. So these two figures are said to be congruent. Similar figures as well as congruent. That's why all congruent figures are always similar to each other. Now I am going to take two triangles. See, are these two triangles are similar? Yes. Why? Because these two triangles have same shape. But can I say these two triangles are congruent? No. Why? Because these two figures have same shape but they doesn't have same size. So these two triangles are similar figures only but not congruent. Like this way we can classify what are similar figures and what are congruent figures. And now coming to the congruency, let me explain some axioms of the triangles. And the first thing is Sas axiom. Sas axiom. What it means? What is the use of this one? If any two triangles are said to be congruent, they should follow some rules. Among that, the first one is Sas Axiom, which means that in a triangle, two sides and included angle will be equal to the corresponding two sides and included angle of the another triangle respectively. Then we can say those two triangles are congruent triangles. Here see, two sides and included angle. Here S stands for side and A stands for angle. Here how many sides will be? Two. SAS na. Here angle is between these two sides. So we can give the definition of this axiom is two sides and included angle of one triangle are equal to the corresponding two sides and included angle of another triangle respectively. Then we can say those two triangles are congruent. Let me show you diagrammatically. Now here I am going to take two triangles. Here I am going to take the triangle ABC and I am going to take one more triangle which is DEF and two sides and included angle. Here I am going to select this side and this side and the included angle is this one. Two sides and included angle of one triangle are respectively equal to the corresponding two sides and included angle of another triangle. Then we can say these two triangles are congruent to each other. The congruency symbol is this one. We can say these two triangles are congruent to each other. Let me show you in tabular form. Here I am writing triangle ABC and here I am writing triangle DEF. And see which side? Here AB is equal to DE. AB is equal to DE and next BC is equal to EF. And the angle, included angle is here angle ABC. Here angle ABC is equal to angle DEF. DEF. So we can say triangle ABC is congruent to triangle DEF. By which axiom? Sas axiom. So here triangle ABC is congruent to triangle DEF by Sas axiom. Let us see one more axiom. And the second axiom is here ASA. ASA. ASA axiom. In the definition itself it has a meaning. See, like previous axiom, here in that there are two sides and one included angle. Here A stands for angle, S stands for side. Here two angles and included side will be. So we can give the definition of ASA axiom is in a triangle, two angles and included side are respectively equal to the corresponding two angles and included side of another triangle. Then we can say those two triangles are congruent to each other. I am repeating, two angles and included side of a triangle are respectively equal to the corresponding two angles and included side of another triangle, then we can say those two triangles are congruent to each other. Let me show you diagrammatically now. And here I am going to take two triangles. And first of all I am going to take which is P, Q, R, and second triangle I am giving the name X, Y, Z. And here two angles and included side. And here I am going to select this angle corresponding to this one. And I am going to select second angle this one, and this corresponding angle is this one. And side, included side is this only. So I can say these two triangles are congruent to each other. Let me show you in tabular form. Here I am going to take triangle PQR, and here this is triangle XYZ. In this angle PQR equal to angle XYZ, and second angle is angle PRQ. Angle PRQ is equal to angle XZY. Angle XZY, and the included side is here QR, and here YZ. Here QR equal to YZ. So we can say these two triangles are congruent to each other. Why? Because two angles and included side of the first triangle are correspondingly equal to the two angles and included side. So therefore we can say triangle PQR is congruent to triangle XYZ. By which axiom? A is A. In this way we can say these two triangles are congruent. Let me go with one more axiom. And the third axiom is SSS axiom. SSS axiom. What is meant by triple S? Here each S represents sides of a triangle. So simply we can say in a triangle all the three sides are equal to the corresponding all the three sides of another triangle. Then we can say those two triangles are congruent to each other. And let me show you diagrammatically. Now here I am going to take two triangles. And let me give the name which is A, B, C, and this one is P, Q, R. All the three sides of the first triangle correspondingly equal to the all the three sides of the second triangle respectively. Means this side equal to this side, and this side equal to this side, and this side equal to this side. Here see all the sides only, no? So we can say these two triangles are congruent to each other. Let me show you in tabular form. And this is triangle ABC, and this is triangle PQR. Here the side AB is correspondingly equal to side PQ, and here side BC is correspondingly equal to side QR, and here side AC correspondingly equal to side PR. So we can say therefore triangle ABC is congruent to triangle PQR. And the last axiom from this aim is RHS axiom. And the fourth one is RHS axiom. Here the definition subheading itself says R means right angle triangle, H stands for hypotenuse and S stands for side. So in this axiom we are going to take two right angle triangles only. This property is applicable for right angle triangle. Why? Because here R stands for right angle na, that's why. And in a right angle triangle, hypotenuse and any side of the triangle are correspondingly equal to the hypotenuse and any side of the another right angle triangle, and their corresponding hypotenuse and sides must be equal. Then we can say those two triangles are congruent to each other. And now let me show you diagrammatically. And here I am going to take right angle triangles, and this is X, Y, Z, and one more right angle triangle I am going to take, that is P, Q, R, and here it is a right angle and here it is a right angle. Now for this hypotenuse, where hypotenuse means the side which is opposite to the right angle, means this is the hypotenuse, and in the same way here it is the hypotenuse, and the corresponding hypotenuse equal now. And let me select one more side. We can select this one or this one, no problem. Now I am going to select this one, and this corresponding side is this only. So we can say these two triangles are congruent to each other. Now let me show you the tabular form, and here triangle XYZ and here triangle PQR, and here XZ corresponding side is PR, YZ corresponding side is QR, and the right angle here XYZ, angle XYZ is equal to angle PQR, which are equal to 90 degrees. So we can say these two triangles are congruent to each other. Now therefore triangle XYZ is congruent to triangle PQR by RHS axiom. In this way we can prove the congruent triangle, whether they are congruent triangles or not. And now let me take one problem from our material. Let us prove. And the most important thing you have to remember is here, whenever two figures are said to be congruent, their corresponding sides are equal and their corresponding angles also equal. And the properties of the congruent figures, they may be polygons, they may be triangles, whatever they are. And here we have to remember that first one is their corresponding sides are equal and corresponding angles also equal. And let me take one problem from our textbook, and here they given some figure. And here they given in the following figure, triangle ABC and triangle DBC are two triangles such that they given AB is equal to BD, AC is equal to CD. We have to show that those two triangles are congruent triangles. Let me write the problem on the board. In the following figure, triangle ABC and triangle DBC. Triangle ABC and triangle DBC are two triangles, such that AB is equal to BD and AC is equal to CD, and AC is equal to CD. Show that triangle ABC is congruent to triangle DBC, and the given figure like this. ABC and this is DBC, and they given like this. Now we have to prove these two triangles are congruent. First of all, observe this figure. This figure contains two triangles. What are they? They are A, B, C and B, D, C. Now let me write. Let me write in tabular form. First is triangle ABC and the second one is triangle DBC. First, what is given here? AB is equal to BD, right now? AB is equal to BD. So here I am going to write AB is equal to BD. And second thing, they given that AC is equal to CD. Here in diagram also they shown AC is equal to CD. Now let me write AC is equal to CD. Now what I have to do? If any two triangles are said to be congruent, we need one more measurement na, whether that is angle or side. Let me observe this figure. See, can I take BC as common for both the triangles? Yes. Observe here, this BC belongs to ABC as well as DBC also. Here BC is the common side for both the triangles. Common side means which has equal measurement, no? Yes. So I can write BC is equal to BC, in brackets I can write which is a common side. See here, three sides of the first triangle are correspondingly equal to the three sides of the second triangle. So I can say these two triangles are congruent to each other. By which axiom? Yes, here three sides na? Yes, axiom. So at last I can write triangle ABC is congruent to triangle DBC. By which axiom? Yes. In this way I can prove the problem. Thank you. Triangle ABC is congruent to triangle DBC. By which axiom? Yes, axiom. And now let me show you some figures. Now tell me whether they are congruent or not. If they are congruent, by which axiom they will satisfy. Observe these two triangles. Here this side is equal to this side and this side is equal to this side, and included angle. This angle is included these two sides. Here this angle also included to these sides. So I can say these two triangles are congruent. Why? Because which axiom these two triangles are satisfying? Yes, two sides included angle. So by SAS axiom I can say these two triangles are congruent to each other. These two are in same shape and now they are same size also. So I can say these two triangles are congruent to each other. They are Congruent by which axiom? S, A, S. Two sides included angle. Now let me show you one more pair. Observe this. Which axiom they are satisfying here? Yes. Yes, yes, yes. See here, this side equal to this side equal to this side equal to this side. And the corresponding sides are equal. Each side of this triangle is equal to the corresponding side of this triangle. We can say these two triangles are congruent. By which axiom? SCTS axiom. By SCTS axiom, these two triangles are congruent. Now let me show you one more. See this one. Here you can observe that here, see, you can see two angles, and here angle equal to here angle, and this angle equal to this angle, and the included side is this one. Two angles and its included side are equal in both the triangles, and that too they are corresponding sides and corresponding angles. So the two angles and included side of the first triangle correspondingly equal to the two angles and included side of the second triangle. We can say these two triangles are congruent to each other. By which axiom? By which axiom? A, yes, A. And now let me show you one more pair. Observe this. What type of triangles are these? Yes, these are right angle triangles. How can we say these are right angle triangles? Yes, here angle is 90 degrees. What is the hypotenuse in this triangle? Yes, hypotenuse is obviously this one. Why? Because the side which is opposite to right angle, the side which is opposite to right angle is called hypotenuse. This is the hypotenuse. These two are the remaining sides. And now see here, this is a right angle triangle, and here it is 90 degrees and here it is 90 degrees, and this is the hypotenuse and this is the hypotenuse, and these two are equal, and the remaining side I am taking this one, this side equal to this side. So I can say these two triangles are congruent to each other. By which axiom? RHS axiom. H stands for hypotenuse and side. RHS axiom, these two triangles are congruent. In this way, we can learn the axioms. Thank you.